The delta method is the conventional approach in differentiating a function. It is flexible to whichever complicated functions there is to differentiate. However, there are some limits to the approach. Check how it is used here in this example. Welcome to differential calculus. We are to differentiate the function y as equal to 4x raised to negative 3 minus 2 times x raised to negative 2 plus 3x raised to 4 using delta method. We start off by taking out negative exponents in order to proceed to any solution. Thus, the function becomes y as equal to 4 over x cubed minus 2 over x squared plus 3x raised to 4. By following the steps in delta method, we start by changing variables into binomials with deltas. So the function becomes y plus delta y as equal to 4 over the cube of x plus delta x minus 2 upon the square of x plus delta x plus 3 times x plus delta x raised to 4. At this point, there are 4 variables, x and y, with delta x and delta y. So we try to reduce them. That is, by changing y into its function of x. Then we also take the common denominator for the 3 terms on the right, and that is the cube of x plus delta x. The numerators then start with 4 for the first, followed by negative 2 with x plus delta x. Then the third term's numerator becomes 3 times x plus delta x raised to 7. If we try to isolate delta y, we transpose all the other terms on the left to the other side, thereby having delta y as the whole right term less y, which comprises of 4 over x cubed minus 2 over x squared plus 3x raised to 4. From here, strategize how to go about with a simplification. Note that we again need to generate a common denominator for all terms. And also expanding a binomial raised to 7 will be too cumbersome. So this approach of taking the derivative of the whole function will be difficult. What could be an alternative way to go about the problem? Just the same, the function has to be in its positive exponents. But then, we know for a fact that what we have now is a polynomial, which means we can separate each term. And we are gonna do just that. We break the function down into 3 terms, y1, y2, and y3, where y is taken as y1 minus y2 plus y3. So we solve for the derivative of each term separately. Let's start with the first term y1, which is equal to 4 over x cubed. Again, we start by placing the deltas with the variables. So we get y1 plus delta y1 as equal to 4 over the cube of x1 plus delta x1. Next is to change y into 4 over x cubed, which leaves us with 3 variables in the function. Then next is to move all other terms into one group to isolate delta y. We can then simplify the function by taking the common denominator, and that is x cubed with the cube of x1 plus delta x1. The numerator then becomes 4x cubed for the first term, and 4 multiplied by the cube of x1 plus delta x1 for the second term. In order to simplify the numerator, take the groupings out and expand the exponent. The cube of the binomial is then taken using Pascal's triangle, where the coefficients of the terms are 1, 3, another 3, then another 1. We then multiply 4 to each term and get delta y1 as 4x cubed minus 4x cubed minus 12x squared delta x minus 12x delta x squared minus 4 of delta x cubed. We can then cancel 4x cubed, leaving us with the function of delta y as equal to negative 12x squared delta x minus 12x delta x squared minus delta x cubed. They are all divided by x cubed by the cube of the binomial x plus delta x. Then move on by dividing the function by delta x, where we can then cancel some pairs, bringing about delta y over delta x as equal to negative 12x squared minus 12x delta x minus 4x squared all upon x cubed with the cube of x plus delta x. Move to the last step of taking the limit of the function as delta x approaches 0. The limit then takes all terms with delta equal to 0, cleaning the function of delta y over delta x into negative 12x squared over x cubed with another x cubed. Cancel some x's and get the first term as negative 12 over x raised to 4. This is the derivative of the first term. Next is to solve for the derivative of the second term, which is 2 over x squared. Do the same process all over, starting with incorporating the deltas into the variables, making y plus delta y as 2 all over the square of x plus delta x. Change y into 2 over x squared. Then, isolate delta y by transposing all other terms to the opposite side. With two separate fractions, look for a common denominator in order to proceed with the operations. The common denominator is x squared times the square of x plus delta x. This makes the numerator 2x squared minus twice of the square of x plus delta x. Expand the square in order to eliminate terms, after which distribute 2 among the terms in the trinomial. By doing so, it is also observed that 2x squared can be cancelled out, leaving the function of delta y as negative 4x delta x minus 2 delta x squared all over x squared times the square of x plus delta x. After simplifying everything, divide the function by delta x, and this would eliminate deltas from the numerator, leaving the function delta y over delta x as negative 4x minus 2 delta x all upon x squared times the square of x plus delta x. This is the simplified third step, so continue the process by taking the limit of the function as delta x approaches 0. This then zeroes out deltas in the function, leaving delta y over delta x as equal to negative 4x over x squared times another x squared. Take out excess x from the right and get delta y over delta x as negative 4 over x cubed. We then continue with the last term, y, as 3x raised to 4. Place deltas with each variable and have y plus delta y as equal to 3 times x plus delta x raised to 4. Next is to change y into 3x raised to 4. Then isolate delta y by transposing 3x raised to 4 to the other side. Expand the exponents by using Pascal's triangle, where a binomial raised to 4 has coefficients of 1, 4, 6, 4, and 1. Distribute 3 to all the terms in the group and get 3x raised to 4 plus 12x cubed delta x plus 18x squared delta x squared plus 12x delta x cubed plus 3 delta x raised to 4 minus 3x raised to 4. It is then evident that 3x raised to 4 can be cancelled out, leaving the function delta y as 12x cubed delta x plus 18x squared delta x squared plus 12x delta x cubed plus 3 delta x raised to 4. Next is to divide the function by delta x, where there are deltas that can be cancelled out, reducing the function into 12x cubed plus 18x squared delta x plus 12x delta x squared plus 3 delta x cubed. The last step is to take the limit of the function as delta x approaches 0. The terms with delta x then are zeroed out, leaving delta y over delta x as 12x cubed. Now that all three derivatives are determined, we can then place them in a single equation, where the derivative of y is then the derivative of y1 minus the derivative of y2 plus the derivative of y3. Those are negative 12 upon x raised to 4 minus negative 4 over x cubed plus 12x cubed. The second term then takes a positive operator, finalizing the derivative as negative 12 over x raised to 4 plus 4 over x cubed plus 12x cubed.